Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi zidni ilma. Okay guys, this is going to be the third part of the introduction to periodic table video session that we have started 2 videos back. So this is going to be the group 3, the Boron family, and previously we have discussed about the first and the second group, which were named as alkali metals and alkaline earth metals, which actually belong to the S group. Now we are moving towards the Boron family, which is the group 3. And why it is called as Boron family? Because the topmost element which is present at the top of the family is called as is actually the element boron. The boron family is named after the first element in the family. Atoms in this family have 3 valence electrons, so that's why it is grouped in the third group of the periodic table. This family includes a metalloid boron and the rest are metals. So this is something which we call as variation. So we have previously, when we were discussing about the chemical or physical properties of any elements which are present down the group, we use the word similar, not the same. So there are variations, same like that. The one you are seeing right now is boron with being a metalloid nature, and the rest of the things, the rest of the elements which are present down the group are actually metals. Aluminum metal was once rare and expensive. Now the most abundant metal in the earth crust is sometimes considered as a disposable metal. So according to its nature or according to its the frequency that it is found, it can be just used and disposed of. So this is no more a rare element in the earth crust. So these were the boron family and the thing you can see right now is actually the chips or the chipsets of any computer, and they are made up of silicon and germanium, and these are most importantly semiconductors. So they do not conduct electricity as good as to the real metals that we have talked about in transition elements, but they still can conduct electricity, and these are called as semiconductors, and they are mostly used for computer chips, etc. Now the fourth family that comes under the name of carbon family, they have 4 electrons in their valence or outermost shell, contains 2 metals and 2 metalloids and 1 non-metal carbon. Reactivity varies solids at room temperature. So these are something which are actually the part of carbon family members. And if you go into the details of these structures which are present as a part of carbon family members, you can see we have carbon, silicon, germanium, tin and lead. So the things that we have, carbon and silicon, are basically types of metalloid and non-metals, and then we have germanium, tin and lead, which are actually metals. So 2 metals, 2 metalloids and 1 non-metal, which is actually carbon. Then we have the next family, or simply called as group 5 or nitrogen family. This is going to be the family that we are going to discuss in the form of nitrogen family, and that is the nitrogen family is named after the element that makes up 78% of our atmosphere. So we all know that nitrogen is present in an as an atmospheric gas around us, and almost 78% of our atmosphere, which is containing different types of gases as to make air as a mixture. One of the major content is nitrogen gas. So this family includes non-metals, metalloids and metals. Atoms in the nitrogen family have 5 valence electrons, so that's why they are grouped as group 5. They tend to share electrons when they bond. Other elements in this family are phosphorus, arsenic, antimony and bismuth. So most of them are actually metals and metalloids, apart from this nitrogen, which is gaseous in structure, so definitely it is a non-metal. Then you can see there are different purposes or different presence of nitrogen family that we can see is nitrogen in the atmosphere. Then we have a matchbox, you can see is one of the things from phosphorus, which is used for any sort of chemical which can ignite. Then we have group 6 or oxygen family. obviously the topmost element of this family is oxygen, and that's why it is named as oxygen family. And the group number 6 reveals that it has 6 electrons in their valence shell. Most elements of the family share electrons when forming compounds, so oxygen is the most abundant element in the Earth's crust. It is extremely active and combines with almost all elements. Many things that stink contain sulfur, rotten eggs, garlic, skunks, etc. So the oxygen family mainly contains oxygen, sulfur, selenium, tellurium, and polonium. So anything especially that we have specific smells, stinky smells, that is just like a rotten egg that contains mostly sulfur in them. These are the structures like garlic, eggs, and all that you mostly come across has sulfur in it. Then the group 7 or the halogens are called as the group 7 members, and these are basically halogens which have 7 electrons in their outermost shell, and they are most active nonmetals. Why they are most active nonmetals? Because first of all, they most of them are gases, gases, liquids, or solids. They can be in the same group. There are the distribution of the topmost, which is chlorine, which is a gas, then the bromine, then is iodine and astatine. So bromine is liquid and iodine, astatine are basically solids. So these are the elements which have only 7 electrons in their outermost shell, and the main importance of this shell is only that they need 1 electron to make its outermost shell complete. And if we talk about the meaning of the name, that is halogen, that means halo. Halo is the word that means in Greek that's salt, and gen is the word that comes from generating or generation or formation. So the overall halogen means salt formers. So these are some things which actually, when react with any other metals, mostly form salts. Just like, for example, we can talk about if we take example of sodium, that is when react with water, or sodium that reacts with chlorine, that is the chlorine is from halogens and the sodium is from group 1, that is mostly make the table salt, that is NaCl. So different salts are formed when these halogens actually bond with other elements. Here you can see there's a water bath or the swimming pool which shows the presence of chlorine. Chlorine is one of the very important elements in the same group of halogens, which is actually germicidal in nature. So because of its antiseptic activity or the germicidal quality, this gas is actually liquefied and used in swimming pools for germicidal purpose or germ killing. And then you have like fluorine, which is a part of your tooth that is required for good tooth structure, and the iodine, which is used for your injuries as an antiseptic. The last group, or group 8, is also called as noble gases or inert gases or non-reactive gases. So these are the elements which are present in the last group of the periodic table, which are mostly inert or non-reactive in nature. Why they are non-reactive in nature? Because they have their outermost shell filled with 8 electrons, or 2 following the duplet or the octet one. Noble gases are colorless gases that are extremely unreactive. They are inactive because their outermost energy level is full. They have a full valence shell. Because they do not readily combine with other elements to form compounds, the noble gases are called inert. The family of noble gases includes helium, neon, argon, krypton, xenon, and radon, and all the noble gases are found in small amounts in the Earth's atmosphere. So that was all for the periodic table. And these were all the things that we had to discuss. Here the introduction of our periodic table completes. For next video, inshallah ta'ala, I will be explaining the properties or the periodicity of different properties that an element exhibits. And this is something we will be inshallah sharing in our next video. Till then, Assalamu alaikum.